Imagine a universe where adding 1 and 1 gives you -1. It sounds crazy, right? But what if the most basic math we know was different? Our universe is full of surprises. What we think is impossible might just be waiting to be discovered. Think of black holes. They were once just an idea from Einstein's wild theories. Now, we have pictures of them. So, let's take a journey into a universe where 1 + 1 = -1 and see what mind-blowing wonders await us. Our adventure starts with a simple question. What if our universe wasn't built on the math we know? What if at its core something as fundamental as addition worked differently? Buckle up because we're about to explore a reality that's stranger than fiction. Einstein taught us that space and time are connected like a fabric. Massive objects warp this fabric, creating gravity. But what if the math behind gravity was flipped on its head? In our 1 + 1 = -1 universe, space itself might be twisted. Imagine a universe where straight lines curve in strange ways and distances change depending on where you are. That's the kind of weirdness we're talking about. Gravity, instead of pulling things together, might actually push them apart. Stars and galaxies would form in completely different ways. Black holes might act like cosmic cannons, shooting out matter instead of sucking it in. This universe is disorienting, challenging everything we thought we knew about the cosmos. But keep in mind, the universe is under no obligation to make sense to us. E=mc², Einstein's famous equation, tells us that matter and energy are two sides of the same coin. This elegant formula encapsulates the profound relationship between mass and energy, suggesting that they are interchangeable. It's a cornerstone of modern physics, revealing that even the tiniest amount of mass can be converted into a tremendous amount of energy, and vice versa. But in our topsy-turvy universe, this relationship could get even weirder. Imagine a universe where the rules as we know them are bent, twisted, and sometimes completely broken. The very fabric of space-time could behave in ways that defy our current understanding, leading to phenomena that seem straight out of science fiction. Imagine negative energy, a concept that seems like something out of Star Trek. Negative energy isn't just a theoretical curiosity, it could have real implications for the nature of our universe. It might be the key to unlocking new forms of propulsion, or even creating stable wormholes for faster-than-light travel. What would it even mean for energy to be negative? Could it counteract the effects of positive energy, leading to new forms of equilibrium? Scientists are still grappling with these questions, but the possibilities are tantalizing. Negative energy could potentially reverse gravitational forces, leading to phenomena that are as fascinating as they are perplexing. Could it create matter with anti-gravity, making it fall up instead of down? This isn't just a whimsical idea, it's a serious scientific hypothesis. If negative energy can indeed create anti-gravity effects, it could revolutionize our understanding of physics and open up new avenues for technological innovation. Then there's antimatter, the nemesis of normal matter. Antimatter is like a mirror image of regular matter, but with opposite charges. When matter and antimatter meet, they annihilate each other in a burst of energy, a process that releases enormous amounts of power. In our universe, they annihilate each other in a burst of energy. This annihilation is not just a destructive process, it's also a potential source of immense energy, which could be harnessed for various applications, from power generation to propulsion systems for interstellar travel. But in this strange new reality, maybe they'd do something completely different. What if, instead of annihilating each other, matter and antimatter could combine to form new exotic particles? These particles could have properties that are entirely different from anything we've ever seen, leading to new forms of matter and energy. Perhaps they'd combine to form exotic new particles, the building blocks of a whole new kind of chemistry. This new chemistry could lead to materials with unprecedented properties, revolutionizing everything from medicine to materials science. Our 1 + 1 = -1 universe is a breeding ground for the bizarre, where the familiar laws of physics are thrown out the window. In this realm, the impossible becomes possible, and the boundaries of our understanding are constantly being pushed. And we're just getting started. The journey into this strange new world is only beginning, and who knows what other mind-bending discoveries await us. The future of physics is as exciting as it is mysterious, promising to challenge our perceptions and expand our horizons in ways we can scarcely imagine. Quantum mechanics, the physics of the very small, is already a mind-bending field. Particles can be in multiple states at once, and uncertainty rules. Now imagine adding our wonky math to the mix. In this universe, the famous Heisenberg uncertainty principle, which limits what we can know about a particle's position and momentum, might work in reverse. Or maybe it would lead to entirely new forms of quantum weirdness. Imagine particles spontaneously popping into existence from nothing, or quantum tunneling happening on a macroscopic scale. Objects might teleport across space or even backward in time. The possibilities, while mind-boggling, are endless. Our journey through this strange universe shows us that even the tiniest tweak to the fundamental laws of nature can have enormous and unpredictable consequences. Section 5. The Big Bang's Negative Twin. The Big Bang Theory describes the birth of our universe from an incredibly hot, dense state. This monumental event, occurring approximately 13.8 billion years ago, set the stage for everything we know today. From the smallest particles to the largest galaxies, all emerged from this singular moment of creation. But, in a universe where 1 + 1 = -1, the Big Bang might have been a very different event. Imagine a reality governed by entirely different mathematical principles, where the rules we take for granted simply don't apply. In such a universe, the very fabric of existence could be woven from threads of negative energy and antimatter. Imagine a negative Big Bang where the universe starts from a point of negative energy and expands outward. This concept challenges our understanding of physics, pushing the boundaries of what we consider possible. Negative energy, a mysterious and largely theoretical construct, could give rise to a cosmos that behaves in ways we can barely comprehend. Or maybe the universe oscillates, expanding and contracting in an endless cycle of cosmic breaths. This cyclical model suggests that the universe is not a one-time event but a perpetual motion machine, constantly renewing itself. Each expansion and contraction could bring about new forms of matter, energy, and even life. The laws of physics as we know them might have emerged gradually, like a cosmic phase transition. Just as water turns to ice, the universe could have undergone a series of transformations, each one bringing new physical laws into play. These transitions might have shaped the universe in ways we are only beginning to understand. Our universe, with its familiar math, could be just one pocket of reality in a much larger multiverse where other mathematical possibilities play out. In this grander scheme, countless other universes could exist, each with its own unique set of rules and constants. These alternate realities might be governed by principles that are utterly alien to us. The possibilities are as endless as the universe itself. With each new discovery, we peel back another layer of the cosmic onion, revealing more questions than answers. The vastness of space is a testament to the boundless potential for discovery and wonder, and it makes you wonder what other strange and wonderful universes might be out there, hidden from our view. Could there be realms where time flows backward, or where the very concept of time doesn't exist at all? The mysteries of the cosmos are far from being fully understood, and each new theory brings us one step closer to unraveling the secrets of the universe. Section 6. Life finds a way strangely. Life as we know it relies on the delicate balance of chemical reactions governed by our universe's laws. But could life exist in a universe with fundamentally different math? It's hard to even imagine. The building blocks of life as we know it might not form. Instead, entirely new elements and molecules governed by alien rules could give rise to life forms beyond our wildest dreams. Imagine creatures made of negative energy feeding off the fabric of space-time itself. Or life forms that exist in multiple dimensions, perceiving time in a non-linear way. The possibilities are limited only by our imagination. Life, it seems, has a knack for finding a way, even in the most unexpected of places. And in a universe as strange as this one, who knows what wonders await us. Section 7. Math gets philosophical. Our exploration of this strange universe forces us to confront a fundamental question. Is math invented or discovered? Is it a human construct, or is it the language of the universe itself? If 1 + 1 = -1 in another universe, does that mean math is just a set of arbitrary rules? Or does it point to a deeper, more fundamental level of reality where different mathematical possibilities can exist? This question has puzzled philosophers and mathematicians for centuries, and our hypothetical universe only deepens the mystery. It suggests that the nature of reality itself might be far stranger and more wondrous than we ever imagined. Our journey into the world of what if reminds us that the pursuit of knowledge is about asking bold questions and challenging our assumptions about the universe. Section 8. A reality check. Before we get too carried away with our mind-bending exploration, it's important to remember that our 1 + 1 = -1 universe is purely hypothetical. This concept, while fascinating, serves as a thought experiment to challenge our understanding of reality. As far as we know, the laws of physics are consistent throughout our observable universe. These laws, such as gravity and electromagnetism, have been tested and confirmed through countless experiments and observations. But that doesn't mean we should stop asking, what if? What if there are aspects of the universe we have yet to discover? What if there are dimensions or realms beyond our current comprehension? Imagining alternative realities, even impossible ones, can help us to better understand our own universe and the fundamental laws that govern it. These imaginative exercises push the boundaries of our knowledge and inspire new lines of scientific inquiry. By pushing the boundaries of what we think is possible, we open ourselves up to new ways of thinking and new discoveries. This mindset has led to some of the most groundbreaking advancements in science and technology, and who knows, maybe someday we'll find evidence that some of our wildest imaginings aren't so far-fetched after all. The history of science is filled with ideas that were once considered impossible but later became accepted truths. Our exploration of the 1 + 1 = -1 universe, while purely hypothetical, highlights the power of imagination and the importance of always questioning our assumptions. It reminds us that the pursuit of knowledge is an ever-evolving journey, driven by curiosity and the desire to understand the mysteries of the cosmos. So, as we continue to explore the vast expanse of space and the intricacies of the quantum world, let us keep our minds open to the endless possibilities that lie ahead. After all, today's fiction could be tomorrow's reality. Section 9. The Wonders of What If. So, while a universe where 1 + 1 = -1 might seem absurd at first glance, it leads us on a fascinating journey through the strange and wonderful possibilities of the cosmos. It reminds us that the universe is full of surprises and that our understanding of it is constantly evolving. By embracing the power of what if, we open ourselves up to new ways of thinking about the universe and our place within it. And who knows, maybe someday, our wildest imaginings will lead us to even more profound discoveries about the nature of reality itself. The universe is vast, mysterious, and full of wonder. Let's never stop exploring it.